Good morning. That is 11 o'clock, so we are going to kick things off. I can see a few people joining us, and I appreciate people will be finishing calls and coming to join us. So as people join, you can see that today we are going to be covering cloud cleanup and AI innovation, fixes, fortification, and future-proofing. So my name is Michael Cafferty. I'm a business development manager in the digital solutions team at CACI. For those who don't know, CACI is a UK-based technology and data consultancy that helps organizations transform through data architecture, digital solutions, and managed IT services. And today we have two very experienced technical leaders joining us from the business. Matt Pearce is our head of cloud and DevOps in the digital solutions team at CACI. He has a wealth of experience supporting our enterprise customers through complex cloud migration and optimization projects. And Matt works with tech leaders and tech teams of all sizes to promote best practices in DevOps. Also joining us is John. John is a data and cloud technology expert, leading CACI's data tech and AI architecture practice. He advises organizations on their data and AI strategies, often leading large technology transformation projects. So both Matt and John have plenty of hands-on experience and plenty of battle scars to cover today's subject matter. So what are they going to be talking about? Onto the agenda. First of all, we have got Matt, who will be covering cloud optimization and innovation, followed by optimization before transformation, and then finally finishing up on hybrid complexity and security blind spots. Then we will pass to John, who will be covering designing for AI in the cloud. After that, we will be finishing up with a live Q&A. So throughout the conversation, please do add your questions into the Q&A box. We will try and get through as many of them as possible at the end. It is anonymous, and any that we don't have time to cover, we will follow up with you after. Now, this conversation is actually part of a series which has contributed towards our ebook, which is now available to download. So this is the Cloud Clean-Up Playbook that covers 5 essential fixes to address before you innovate. So these 5 mistakes are common, and the ebook addresses 5 common mistakes and how to avoid them. So these 5 mistakes here. Please do scan the QR code. That will take you through to a download page, and you can read that in your own time. We'd love to hear your feedback. Are you facing the same challenges? Are these mistakes common in your business? Is there maybe something unique to your business or your industry that you feel might not be covered? Or if you just want to have a more in-depth conversation around some of the challenges that are covered, there'll be contact information at the end. Do get in touch, and we'd like to have a more specific conversation around you and your business. I'll give you another second in case anybody wants to pick up on the QR code. And then I will be passing over to our first contributor, which is Matt.
Okay, thanks, Michael. Thanks for the mention of the battle scars there. Fortunately, we have a very good makeup department here at CACI, so you can't see them right now, hopefully. So we're going to start with cloud costs. Are they really, can you say they're truly hidden? And I guess in our experience, it's kind of a yes and no. There's so much information that you start to see in your billing console and cost optimization console once you start accruing costs. But the problem can be one of being able to see the wood from the trees, if you like. So you can see what you're spending your money on quite easily, but not necessarily why. For example, you might be led to an underlying technical issue by a cost anomaly detection alert. You might be seeing you've got some big increase in network egress charges, but you're going to need potentially your DevOps team to examine things like VPC flow logs to determine the actual cause. It's incredibly interesting. Billing info is inextricably linked to your platform health and operational events, and so there's plenty there. And it's not a dark art. There's lots of tools and automation to help but you need people who understand your architecture and technology stack and workload characteristics. And if you've got a lot of workloads, potentially you may even need to do a bit of data engineering and analysis because you've just got so much data. I mean, one of the things, the key points I'd like to finish this slide on is that, in our experience, good engineering teams really do care about cost optimization. It's in their nature not to want to set large piles of cash on fire for no reason. And so the best possible way to deal with it, which I appreciate is not always easy in large organizations, is to kind of engage your technical teams in cost optimization at all times. Moving on to the next slide, optimization before transformation. And it's not a difficult one. It's not difficult to know what to do. It's obviously difficult to actually do it. You need to start with sensible architectural foundations, taking into account the size of your organization, the sectors you operate in, the workloads you need to run. And I think, importantly, the level of maintenance overhead you're prepared to bear versus the level of control you require over your technology. Some things are absolutely essential. Obviously, you need to be able to break down your overall estate into individual, although possibly interdependent workloads, and describe everything those workloads need to be able to run. Clarity is key. We need to be segregating our workloads into their own logical containers, whatever those might be. Separate production and non-production, and centralizing common services where we can, like networking components and security logging. And there are features and architectural patterns out there to make this that are readily available to help us to do this. It could be a simple multi-account strategy, or going all in with a sort of a landing zone based implementation and organizational units. Moving on to hybrid. Clearly hybrid is here to stay. I think most organizations will have, or of any size, will have that complexity that they're going to have to live with and embrace. You'll be using potentially AWS, GCP, Azure, likely to be using Office 365 in a lot of cases, and you're going to have some stuff on premise too. And so it's here to stay. We need to embrace it, and we will need some cross-platform expertise. So not everybody needs to know all of the platforms, but you're clearly going to need people that understand on-prem networking, AWS networking, Azure networking, etc., and the kind of identity and access management solutions that go with those platforms. Moving on to security blind spots. I mean, we have great built-in tooling available today across all platforms to help us, eliminate blind spots, whether that's AWS config and guard duty and inspector, for example, or defender on Azure. But of course, we've got to enable those things from the start and make sure our engineering teams are given the time to understand the findings, mitigate the findings, not just once a year for an annual pen test, but as part of BAU vulnerability management, and ideally mitigating, in advance, in the kind of shift left manner that's very common in the DevOps world. And of course, if you build from a consistent landing zone style base, with preventive and detective guardrails already active, it makes things so much easier. I guess finally, because we've got great tooling at the infrastructure level to help us, find and eliminate blind spots, we can focus a bit more on those harder to find vulnerabilities, at the application layer and with complex attack chains that will tend to require manual effort from skilled testers. It relies on their kind of security and curiosity and determination to find. So moving on, that's me done for now. We're going to move on to my esteemed colleague, Jonathan Eade, who's going to talk to us about lots of exciting stuff in the AI world. Take it away, John.
Thank you, Matthew. That was really informative, and from those that master the makeup department really has hidden those battle scars well. So I'm going to talk today about design for AI and why some of the real sort of core principles that Matthew's spoken about there in terms of defining a foundation for your cloud and cloud architecture is so important if you wish to implement AI and scale up AI. So there's loads and loads of quotes out there on the role of AI and the future of AI, especially with regards to businesses and also technology businesses, or any business that is implementing technology or data services or cloud architecture. So loads to pick on. There's loads to pick from. What I'm talking about here today is this really good quote here from Ginny Rometty, former CEO of IBM. She says about AI will not replace humans, but those who use AI will replace those who don't. And I think we've all probably seen that in some way or some shape or form with our own organizations, whether it's the use of sort of co-piloting tools or AID type methodologies to enable us to do things quicker or faster. And whether we've made a conscious decision to adopt those or not, most organizations have started to adopt those tools. I can take this one step further, and I talk about AI in terms of the fact that it's not going to replace companies, but those companies that utilize AI effectively will dominate those that don't. So whether we like it or not, AI is amongst us. AI is going to proliferate throughout all of the technology platforms that we start to deploy, whether consciously we've made that decision or not. So they are part of it. And so to engineer foundations to allow those AI models to thrive and succeed is really important for all of us. Conversely, if we fail to architect or design foundations or cloud platforms to effectively serve those AI models within those platforms, they'll have some real issues with regards to optimization, cloud costs, and also security. So I'm talking a little bit about today about how we can mitigate for those potential failures, and how we can build those foundations to enable us to deploy AI models more effectively. So what does AI mean to you? And there's lots of terms bandied around, and I'm probably not going to do loads of justice here by sort of simplifying this, but I just wanted to get everyone on a bit of a common ground when we talk about AI. So what do we mean by AI? So number one could be sort of AI agents. I think most organizations have seen this, especially with the sort of widespread sort of release and adoption of LLM kind of NLP type bots or chatty bots, where we have deployed, let's say, sort of web agents or chat bots or any kind of NLP, sort of natural language processing interfaces that allow either consumers or customers of an organization, or even sort of internal consumers of data, the ability sort of to talk to sort of a simulated agent one way or the other. That's a really sort of common use case, and certainly that sort of the widespread use of LLMs is really sort of common use case within those agents. AID, sort of AI decisioning, again, really common in a couple of ways. Either organizations that have consciously deployed this internally themselves or built their own AID models, but a kind of more common, I would suggest, is whether you've made a conscious decision or not, you most likely in the organization probably have installed or deployed like a SaaS product which is using some kind of AID elements to it. Most MarTech AdTech systems certainly are, probably most CRM systems are. Most systems now have some kind of AID logic within inside them. And then lastly, sort of AI, sort of a general kind of catch-all term. And what I reference here is organizations that have made that decision to build their own AI models in-house, either deploying, let's say, sort of common LLM models, which are now kind of quite commoditized through most cloud providers, or utilizing kind of broader AI services such as things like Bedrock and AWS, or just to sort of using sort of common Python libraries. So AI can mean a lot of things to a lot of people. I think generally speaking, the types of workloads they have, the impact they can have on cloud architectures is quite universal. So either that being AI agents, if you've installed that, AID from a SaaS component perspective, or AI if you've built your own AI models in-house and you are utilizing and deploying those. So what type of challenges can they have for your architecture? So broadly speaking, they come in, I would say, sort of three main categories, sort of data. So all AIDs or all AI models, in order to effectively work, need access to quite often a broad spread of data, especially sort of LLMs, and they can often be sort of locked away in source systems. So having access to not only that data, but also having access to good quality, accurate data is really, really important. And also the optimization of the data can have a massive impact on the effectiveness of those models, the accuracy of the models, also the cost and performance of those models. Integrations, and I'll talk a little bit about this later. as you deploy more models, there is potentially a tendency to, if you haven't planned this out, to have almost like a point-to-point integration between models and source systems without thinking about what is a broader architecture and broader framework to deploy. Those integrations can obviously lead to a massive sort of cost, massive management overhead and burden. Last on this point is general sort of management of the overall infrastructure, especially if you haven't planned out and designed that architecture. So just diving into those individually. So with regards to data, if you are a large organization, potentially with a hybrid stack, as Matt referenced, or even potentially with some sort of long-term, sort of larger sort of on-prem legacy databases, or even actually just some more sort of operational EDW or sort of transactional data warehouses, those source systems often are either inaccessible to activation platforms such as AI, AIDs, and AI agents to access the data, or most often, most commonly, the technology or the way that data is modeled means those source systems are unprepared for the types of workloads that AI models are going to be thrust upon them. There's often little unification as a sort of reference with, especially with things like AI agents and especially with LLMs, there's potentially a broader requirement for much broader unification of data, especially sort of customer data, which is often held or preserved within those source systems. That lack of unification means that often those models can sometimes produce inaccurate results or incomplete results. And the last point here is the suboptimal modeling piece. So, and again, I'll talk about this in the next couple of slides, but if you're trying to access data from what might be a kind of more traditional EDW or sort of operational system, or potentially even like a data lake, potentially, that modeling or the way the data is modeled in those systems can have a massive impact on how those models run, how long they run for, the performance of those models, or the accuracy of those models, and just generally kind of the output they produce. So it's really important we think about what is the modeling of data required to best serve those AIs. Integrations. And again, this goes hand in hand really with the previous points about data and access to data. So number one, it could be that data is just sort of locked away in those source systems and there is no ready access. So the challenge of the architecture means that if you obviously are deploying AI, sometimes you might be creating almost like point-to-point integrations with those source systems, creating a big burden with those integrations. That can then lead to increased complexity as you build out those point-to-point integrations, meaning your architecture becomes a bit of a spaghetti junction of point-to-point integrations between AI and back-end data systems. That then, of course, then leads to that management overhead. And talk about management more generally, more broadly. Number one, without having potentially the unification or modeling in place, or even potentially with the integrations not following a framework or common architecture, that can lead to uncontrolled inflated costs, especially with regards to potentially not being aware of what type of workloads those AI models are inflicting or running through those source systems, and if those source systems aren't potentially optimized well for those types of workloads, then that can increase those costs. That can go then hand in hand with those traceable workloads. Again, by not having unification, by not having systems in place to unify the data, but also potentially not having systems in place where you have a common integration framework, those workloads where you are running workloads or running read-write events against those source systems can become untraceable, again, leading to risks. And the worst point here potentially is the fact that this could introduce security risks, either by not understanding or not monitoring what those integrations are, but also with regards to not modeling your data appropriately, leading to inaccurate results. You can potentially lead to what might essentially be a data breach by serving up incorrect results to your consumers or clients of your AIs. So what are those workloads, what are those AI characteristics, and how might we resolve them? So number one, performance. Especially if you're working in an environment where you have, let's say, like Matt was saying, about hybrid systems or multiple, more sort of traditional operational systems where they're also housing data or sort of mastering warehousing data, it's really important we think about how we can draw those workloads away from those source systems and into AI specified solutions which are optimized for those types of workloads. Having those workloads sat within those source systems can massively impact the sort of BAU operations that are going on, but also ultimately they're not going to be as performant you need, effectively impacting the performance of those AI models. Accuracy. So I'm going to talk a little bit more in the next section about semantic layers, but this is a term that it's been around for quite some time, but certainly gained more popularity recently, especially with regards to things like LLMs, NLPs, but actually is very broadly applicable to most AI models. Using semantic layers, which is a way of modeling the data, which is very much specifically focused on the types of outputs you're looking for your AI models to produce. The semantic layers can unify the data and model the data in a way that makes that most likely to be accurate, because it's focused on those types of prompts you're sending through those models, but also it means that it has the right data in the right place to ensure or guarantee that accuracy and reduce the propensity of things like hallucination. Again, with regards to optimization, again, this is something that's gained more popularity recently, especially again with LLMs. Utilizing things like vector databases alongside semantic layers to reduce requerying and to improve context or model context and reduce token usage can be something that can potentially be really worthwhile exploring. Vector databases ensure that models aren't having to rerun the same queries over and over again, but also means they're not having to, also means that you can improve the context understanding of a model by grouping data together at a database level rather than at a compute level. And then the final point here is integrations. It's really, really important, especially if you're looking at an area, especially if you're looking at deploying potentially multiple different AI models or AI agents or AID functionality that require access to lots of different data or backend systems. Utilizing a common integration framework to control and manage those integrations is really important. MCPs, model context protocols, is again something which has gained a lot of popularity, I guess, in the last 18 months. That in itself is something I'll talk about in the next couple of slides. Adopting a process or a protocol that's akin to MCPs, not necessarily have to be MCPs, could be really, really important for your organization. So AI in practice. So this is obviously a theoretical, hypothetical architecture, which I'm just going to talk through to bring to life a little bit more around things like vector databases, semantic layers, MCP, integration layers, and how they can be then applied in practice. So this is the slide I failed on in terms of this is a sort of a very much a hypothetical conceptual architecture, very, very, very simplified, just to bring to life some of these components I was talking about. So number one, as we certainly find, I certainly do a lot of work with financial services institutions where quite often they have got a number of data warehouses or data solutions which are built in a quite sort of traditional sort of dimensional model approach, often optimized for batch sort of write and batch read processes. And that data is distributed into disparate systems for the purposes of mastering or modeling that data into specific areas, be it, let's say, product holdings or current accounts or savings, or it might be sort of life insurance or pensions, for example, or customer data. As organizations want to deploy broader models, potentially there's a good chance, especially with things like AI agents or even AID or AI in general, want a snapshot, potentially not all of the data in all those source systems, but definitely a snapshot to have an understanding of how a consumer is performing across how a consumer is interacting or performing across all of those source systems. Number one, that data often is not always available. But number two, probably the biggest issue, at least for me, I think, is the fact that those sort of back-end databases, they are optimized for kind of batch read, batch write process, and they're not necessarily optimized for very, very chatty integrations to them. And that's either based on the sort of technology they're sat in, based on what sort of analytical processes, more the transactional processes, but then also the actual modeling themselves, often being kind of heavily normalized, focused on more sort of dimensional modeling, means that the querying run against them often non-performance. So developing a semantic layer to sit on top of those source systems to unify not necessarily all of that data, but certainly some of that data into sort of a common layer of an understanding of who that consumer is, or whatever the AI model is trying to consume across those source systems. Bringing that up and promoting that in semantic layer can be really, really important for a number of different reasons. Number one, you're unifying the data, so there's less of a requirement for those AI models to go around, sort of fish around those source systems to try and piece that data together, often doing it incorrectly, and obviously that can then in turn affect performance, but also then means you're unifying that data into an architecture which is more performant for high volume of low demanding queries, just something that's trying to retrieve lots and lots of data points really, really quickly. The type of database you would essentially see behind sort of back-end application example. But then also with in terms of more sort of semantic modeling, semantic layer modeling, the data is then modeled into a way which is specifically engineered around those use cases. So the types of answers those AI models are trying to consume. Most people talk around, especially with regards to LLMs, around sort of prompt engineering in the respects that you are designing those LLMs or the front end of the LLMs to based around sort of the prompts you might be running against those databases. This is kind of a build on that in terms of the respect that those semantic layers have data modeled in a way which are based on the types of questions or prompts you might be asking it to make it more performant and more likely to be accurate. I referenced previously around sort of integration frameworks or MCP, so Model Context Protocol, was something that really kind of came to, I think probably about 12 months ago, maybe 18 months ago. Again, this Model Context Protocol originally was sort of born out of a protocol or integration framework, so to speak, which is focused most commonly aligned to LLMs, but is also has a broader application in terms of AI. I'm using MCP here as a bit of a shorthand to talk around sort of broad integration frameworks. As we can think about, as I sort of referenced a few times, if you are deploying multiple AI models, AI agents, AI consumers, AID services that need access to back-end systems, again, it's almost architecture 101, making sure you have this clear and concise framework, potentially using MCPs to channel those integrations through so we can then go back and retrieve that data either from a semantic layer or other data elements, or potentially from also potentially then serving integrations back into other models as well. And then AI models in themselves. So lots of organizations potentially deploying sort of homegrown models. There's those models potentially have integrations from MCP, but also back into MCP. They'll also have their own requirements for models and data. It might be you have multiple models talking to each other, so AI agents talking to AI models, AI consumers talking to AI models, and then also talking to back-end databases or semantic layers. Having an integration framework that feeds into those, so they're not just standalone processes, is again really, really important. So I haven't talked about previously in this presentation, but I'm going to reference here is observability. So the use of things like MLOps and AIOps. So I could do an entire presentation on MLOps and AIOps in themselves. So I'm not doing it loads of justice by giving you a bit of a bit part here, but observability, understanding the workloads that your models are running on your systems is obviously really, really important. But it goes beyond that. So observability on things like sort of model drift and training data to understand if your models are staying performance or if they're drifting, and they're drifting potentially because your data is changing, so you need to refactor your models, or potentially the training data you're utilizing again needs to be changed or refactored because the environment your models are running has changed ever so slightly. Using MLOps to observe that can be really, really important. So you can then account for and retrain those models. AIOps on the side is separately. We're thinking about using AIOps, especially using sort of LLMs to then interrogate logs in real time. So again, understand the performance of the AI models, how they're running on your system, understand any kind of workload issues or any concurrency issues. Using AIOps to track that, using LLMs to sort of basically read in the logs can be a really important element to monitoring and understanding the workflows on your architecture. sort of the key takeaways, sort of where next. So number one, don't fail to design. AI is inevitable. Sounds quite scary, but everybody will have some degree of AI elements running on their architecture today, whether you've made a conscious decision to do it or not. But most likely because you've got a SaaS application which is running AI on your systems. It might bring in data locally from the SaaS platform. It might also be trying to pull in data from other systems. Understanding where your AI workloads are running and designing an architecture around those is really important. Otherwise, you're going to start introducing AI models in shadow and sleep, and they're going to start impacting your architecture without necessarily being aware of that impact. Number two, data is key. So you got to understand what are the data enablers, what data do your AI models need to succeed and drive. Understand the availability and accessibility of that data, and understand where it is, how they're being utilized, but also think about how the availability and performance models is also really, really important. The benefit of using things like semantic layers. It's not about necessarily having to, I think most organizations are potentially scared about the idea of building like another data lake for AI. This is not about that. This is about thinking about what is your critical and key data required to make your AI models run, and then modeling it to a way to make the most cost effective, most performance, most accurate. It's really important you embrace that, and deploying things at semantic layers can be really important for that. And the final point is, complexity kills. Going back to the first part of the presentation where Matt talks about sort of broader cloud architecture complexity. Certainly, I've witnessed firsthand organizations which have this hybrid stack, this melange of infrastructure is it's sort of virtualized solutions, native solutions, containerized solutions, all within the same architecture, and that then causing potential issues with regards to performance. Layering on additional AI workloads on top of that can really, really impact that further. Complexity kills. Understand where your baseline is right now, and prepare your architecture before you layer on AI. What I'm not necessarily saying here is you need to fix all of your backend architecture issues before you start layering AI. That's probably for most organizations completely unrealistic. But you need to understand what your baseline is first. Understand where you are right now before you start layering on additional complexity. Michael, back to you.
Excellent. Thank you so much, John. That was brilliant. Thank you for everyone who was sticking with us as well. A few technical issues, but we managed to bring it back. So some really interesting key themes there. We're going to jump into the live Q&A in a second, so I'll give you some time to get your questions in. But yeah, some really key themes around, dealing with complexity and having the capability to deal with it. Matt was talking lots around security and making sure you are using those tools available right from the start. And then John with some really interesting stuff there on what AI means to you, and the importance of having the right architecture to take advantage of it. So that was great. And then also, that importance alongside of things like the data involved and the observability. So we'll move through to the Q&A piece. Again, questions are anonymous. We will get through a few of these and as many as we can. Any that we don't cover, we will pick up afterwards. And again, contact information will be available at the end here, just so you can follow up with myself, or I can put you in touch with either John or Matt to have a follow-up conversation. So question number one, just having a quick look through. This one's probably a good one for Matt. So someone's put in here, I read that up to a third of cloud spend is wasted by tech leaders. How do I avoid this happening in my business?
Well, good question. I mean, you could maybe not hire those tech leaders that are wasting a third of cloud spend. I think this is that if you are following one of the very common sort of well-architected frameworks, like say, Amazon's one is used. We use that a lot. There's also the Azure one too. Cost optimization is a key part of, and these are, although they're called well-architected frameworks, they're more than just architecture. It's about how you operate your workloads and how you kind of manage them over their entire life cycle. Cost optimization, put my teeth back in, is a key part of that, and there's no simple answer to to finding and eliminating that third of wasted expenditure. Some of it will be easy, just getting rid of VMs that are doing nothing, for example, if you're lucky enough to have those that you can switch off. But some of it will be really hard. If you discover you've got far too many expensive networking components all over the place and you want to rationalize that down to a smaller set of common networking services, that's a redesign, and that's a project, and it's change, and it's you're going to have to cost that out in itself before you approach actually doing it.
I don't want to give you a chance to add anything to that if you feel you need to. Otherwise, I think I've got another question for you.
I think that's done a fantastic job of answering that question.
Do you want to get the word melange into that one as well, John?
You wait, we've got other ones coming.
So I've got another one here. This one goes back to, I think, something John was covering earlier around challenges in architecture. Someone's asked, we are deploying AI chatbots across multiple customer touch points, but our data sits in many source systems. Do we still need to build a data lake? Yeah, you did mention this. Do we still need to build a data lake, or can we point the chatbot directly at those systems?
Yeah, I did reference it, but let me sort of bring this back again. So, look, I don't know. In this scenario, I don't know what your source systems are, but my guess is going to be is you've got source systems that aren't prepared for AI workloads. Because from an architecture perspective, they're built around kind of sort of more batch read or batch write processes, and they aren't based around the types of workloads that the AI's agents are going to be pushing through them. But also, probably the most critical point is just the model. The data is just not modeled in a way that's optimized for AI or any kind of querying like that. It's not just AI. You wouldn't necessarily just run, I don't know, like reporting straight at them without doing some sort of modeling first. The same kind of tenets are true. The same principles are true with AI. What I wouldn't say, and I don't want to scare people with this, because most organizations have almost certainly gone through a process of doing some data unification, be that in a data lake house, or whatever you want, whatever term you want to use. I'm not saying you need to embark on another project again to do the same thing with specifically AI. It's just not realistic. What I am saying is, though, you need to take into consideration A, the types of questions you're going to be running through those AI agents, but also B, what data access is going to be, what access data they need to have access to, and then think about unifying that data in a way which is optimal for those AI agents. So that isn't necessarily a data lake. I'm not saying you need to bring all the data as the source systems. What I'm talking about is if you are running key questions against those source systems, you need to elevate them away from them, A, to improve performance, but also just to improve accuracy. And you also should be really thinking about remodeling that data to improve the performance of those AI models. So many reasons for that. But just on a real sort of base level, AI models can be really, really expensive. Especially if you're using these LLMs, where they're sort of compute and token-based compute, the more processing they're having to do within those models, the more money it's going to cost, and also the slower it's going to take, and the accuracy is going to decrease. Preparing your data up front preserves that, means you can control that, reduces costs, improves performance, improves accuracy, and also reduces any kind of bottleneck or headache from the source systems. So you definitely should not be pointing AI agents at source systems. You should be elevating them into some kind of unified semantic layer.
Brilliant. Thanks very much. Another question's come through, which is almost, I feel like it's related. So somebody's asked, from your experience dealing with customers or dealing with your clients, to what extent are you seeing enterprise organizations having their own ML ops or AI ops capability kind of in-house already?
I see it happening very little, actually, which is quite interesting. So the term ML ops has been around for ages. And people have been this term has been around for a long, long time, well before we saw this spike in AI activity around sort of ChatGPT. People have been talking about MLOps for a long, long time. So it's not a new thing. It's definitely not a new thing. But I think AI and AI models has become commoditized very, very quickly. It's actually sort of spinning up kind of a boilerplate model using things like Bedrock is pretty. You can do it pretty quickly. You know, tailoring it specifically to your needs and refining it, improve it. Yeah, that takes time, definitely. But actually, it's most organisations, even with a very relatively low-level AI or data science function, have the ability to now deploy moderately complex AI models within their infrastructure if they have some sort of cloud component, cloud architecture with it. So that's become really commoditized, and that came commoditized really quickly. So that capability came really quickly. We've seen a really kind of very slow latter adoption of MLOps and AI ops, and it's not accelerating or catching up at the same speed. I think it's certainly in terms of the deployment of the AI models themselves. I think it's the next thing that people really should be focusing on, actually making sure you have a way of observing those models, understanding how they're running, making sure you can update or train them in real time to deploy them in production, making sure your training data is up to speed, making sure you have the ability to run sort of multiple challenger models, run them against them. Definitely, the adoption of it has not been as strong as I thought it should be, and that is the next thing I think we're going to be seeing over the next 24 months. That slowly sort of catching up from where the AI model deployment has taken off from.
Excellent. Thank you very much. So thank you for that question as well, guys. Moving through a security question. So this might be one for Matt. So what are the security implications of running AI models in the cloud versus on-prem? Are there any risks that are unique to cloud-based AI?
Yeah, good question. Excuse me. I wouldn't say that the security implications for AI models in the cloud versus on-prem really are any different to the security implications of running any kind of workload, on-premise or in the cloud. It's, clearly, and to a large extent, it's going to depend on your architecture anyway. If you're using kind of managed services or kind of helper services in the cloud, say you're using Amazon Bedrock, that's going to be a lot different to if you're just shoving some LLMs onto virtual machines, IaaS type infrastructure and managing it all yourself. So I don't think the considerations or implications are any different. The risks to cloud unique to cloud-based AI, again, it's more about what model you're using. I kind of mentioned earlier on, not to quote myself directly, but you need to consider maintenance overhead versus level of control always for any type of workload. And so if let's say you've got data in a SaaS service somewhere that has got some kind of AI agent enabled, which they all seem to do these days, that's a lot different to if you're actually developing your own services, using Bedrock and based on MCP. So yeah, I'll probably ramble on a bit too long on that one, but hopefully that's given some kind of insight.
Fantastic. Thanks very much.
If I could, can I?
Please, John. If there's a follow-up there, please.
You're going to contradict everything I've just said.
I've never apologised for rambling on too long, and I quote myself all the time. Yeah, if we think about security, all the core sort of tenets that we've always thought about, they are true now as they ever has been. So making sure you've got the right roles, responsibilities in place, making sure you've got the right perimeter security in place, making sure you've got a good handle on what workloads are running on where and who's had access to data. That's there's nothing different with AI. The only thing I will say with AI, and the same goes with security as does with data, is that any flaws that you have in your security posture or your data quality or data accessibility, AI doesn't create new ones, but it over accentuates or makes worse any kind of flaws or any kind of flaws in your security posture, any kind of flaws in your data quality. It highlights them more. And so again, this goes back to what we were talking about when I said about complexity kills. You've got to have that baseline. You've got to understand where you currently stand before layering on AI, because if you have any flaws, AI is going to expose them at a greater speed and highlight them more.
Fantastic. Okay, brilliant. Well, I think we're going to leave it there, unless anyone's got any last-minute questions to come through, which I think we're okay. But really engaging, really interesting stuff from both Matt and John there. And just to finish up, if you do have any additional questions, if you would like to organise a direct conversation with myself, with John, or with Matt around any of the challenges that we talked around today, if you do have any questions or feedback on anything to do with the ebook that is also available, then we'd love to hear about it. That QR code there leads to my LinkedIn if you'd like to connect, or my email address, and we'd be more than happy to have a follow-up conversation around addressing any of the challenges discussed today. So thanks very much for your time, both Matt and John, and hopefully be talking to some of you out there soon.
Thank you, Michael.
Thank you.